Light is a manifestation of a pure equilibrium in space and in time. Light is completely controlled by equilibrium and causality. And equilibrium and causality are the foundations in physics. It has never been realized, but since Isaac Newton has built his classical mechanics theory, he has built his whole theory on one simple rule in physics, in nature, and that is the rule of equilibrium and causality. These belong together. And since Isaac Newton, no physicist has ever grounded his theories on nature. We completely have left nature since James Clerk Maxwell introduced his theory of electrodynamics. It is a mathematical balloon floating in the air and not grounded on anything, not connected to Isaac Newton's classical mechanics, not connected to the fundamental laws of nature, causality and equilibrium. And the same happened with the introduction of Schrödinger's wave equation. It has always been totally unknown where this equation came from. And when Dirac postulated his relativistic Dirac equation, which is in fact the mother of all equations in quantum physics, there was no relationship with classical mechanics, there was no relationship with nature, and everything what has been built in quantum physics is pure mathematics. But physics is not mathematics. It's a completely different subject. Physics is controlled by fundamental laws of nature, causality and equilibrium. And in quantum physics, these fundamental laws have completely been ignored. And if we look at general relativity, it is another mathematical balloon floating in the air, but not grounded, not connected to nature, not connected to the fundamental laws in nature of causality and equilibrium. Theory in physics, which is completely grounded, completely connected to nature. It's completely according the fundamental laws in physics of equilibrium and causality. And for this reason, I found that everything what we calculate in physics is connected to this fundamental law of equilibrium, an equilibrium in space in time, a four-dimensional equilibrium, and causality. And by doing this I have found one simple equation which in fact makes it clear that what we experience in this world, the force, is completely the result of the interaction between corresponding fields. The electric force is a result of the interaction between two different electric fields. The magnetic force is the result of the interaction between two magnetic fields, and the gravitational force is the result of the interaction between two gravitational fields. And it brings us immediately to Einstein's foundation of general relativity based on curvature in space and time, that in this theory there's no curvature of time or space at all. It is just the interaction between two gravitational fields. One gravitational field surrounding a beam of light, and one gravitational field, for example, a black hole. And the interaction between these two gravitational fields makes it that the beam of light will be deflected by a strong gravitational field. It's not a curvature in space and time, it's just the interaction between two gravitational fields in a very simple and exactly corresponding way, as the gravitational fields between the Earth and, for example, the Sun causes the force which forces the Earth to move in an orbit around the Sun. It is all about the interaction between fields. But there's one very important effect we have to realize, is that there is a relativistic effect in Lorentz transformations. The Lorentz transformations cause it that electric fields can manifest as magnetic fields, and magnetic fields can affect as electric fields. And together with these relativistic effects, we find a fundamental equation existing of 5 separate terms which determine everything in physics. It's the interaction between 2 electric fields, it's the interaction between 2 magnetic fields, it's the interaction between an electric field and a Lorentz transformed magnetic field, and it is the interaction between a magnetic field and a Lorentz transformed electric field, and it is the inertia of the field itself. These 5 terms are enough to control everything in physics, to control everything in classical mechanics, to control everything in Maxwell's electrodynamics, to control everything in quantum physics, and to control everything in general relativity. In 2006, an experiment conducted at Harvard University succeeded in reducing the speed of light from 299,792 meters per second to 0 meters per second. This result challenges all that we currently know about light and undermines the foundation of modern physics. A new framework in physics is required to reconcile the century-old scientific law of a constant speed of light with the outcomes of this unprecedented experiment. Lene Howe from Harvard University provides a brief introduction to the experiment she and her team conducted in a Bose-Einstein condensate, which reduces the speed of light from 299,792 meters per second to 0 meters per second. This introduction is followed by a presentation of the new theoretical framework.
We can, these days we can cool atoms down to microkelvin and nanokelvin. That's a few millionths to a few billionths of a degree above absolute zero. So that's pretty freezing cold. And when matter gets that cold, if you can sort of collect a bunch of particles or atoms, cool them down, they tend to form extremely strange states of matter. And a really good example of that is a Bose-Einstein condensate. It's a state of matter that Bose and Einstein predicted some 80 years ago. And it's only in recent years that it's actually been possible to create this state of matter cleanly in the lab, first seen in the summer of '95 by Eric Cornell and Carl Wyman at Gila in Colorado. And I should say also Bose-Einstein condensates, and I'll get back to more precisely what they are, but Bose-Einstein condensates are also the reason explain why we have these strange phenomena such as superfluidity and superconductivity. Now, in my lab, what we have really been focusing on is to use this Bose-Einstein condensate to manipulate light to the extreme. And I will tell you a bit about how we go about slowing light to the speed of a bicycle, just as you heard in the introduction. And I'll also tell you some of our more recent stuff where we can stop and extinguish a light pulse in one part of space And then we can regenerate the light pulse in a completely different location and send it back on its way. So to do these kinds of experiments, of course, we need some cold atoms. And with the kind of temperatures we are talking about, you're not going to do that with your sort of standard household kitchen refrigerator. We need a very special atom cooling setup. And just to show you a few pieces here, I mean, the whole setup is typically 2 by 3 meters to give you the scale. And of course, first of all, we need some atoms. We use sodium atoms at the moment. So we have an atom source where we take a chunk of sodium metal and then heat it to a high temperature, typically hundreds of degrees centigrade, to get a good high vapor pressure so we can get a good emission rate of atoms out of this source. And that's great, that works. The only problem is that because of this high temperature, the atoms will come out with very high velocities, really too high velocity that we can effectively use the atoms. So as soon as the atoms come out of the source, we hit them head on with a yellow laser beam that we send up through the system. And then we use radiation pressure to slow these atoms down very dramatically and very rapidly. And then we can load them effectively into what we call an optical molasses, created in the middle of a vacuum chamber by 3 pairs of counterpropagating laser beams tuned just to the exact right frequency relative to the characteristic absorption frequency of these sodium atoms. And when we hit that right frequency, these laser beams will really act as a molasses, a viscous medium for these atoms and will damp their motion down. And we can cool the atoms quickly down to microkelvin. This is what it looks like in real life in the lab when we are laser cooling. As you can see, we have a room full of optics, lasers, yellow laser beams running all over the place, crisscrossing the lab. And this is a laser table in daylight, and there are quite a few man and woman hours that have been going into building this setup, as you can imagine. We have the condensate trapped in the middle of the vacuum chamber. We illuminate from the side with a coupling laser, and then we launch the probe pulse and send that in along the long dimension of the atom cloud. And then we want to measure the light speed. We simply sit and wait behind the vacuum chamber for this light pulse to come out. And after it has passed through the system, we send a third laser beam up from down below, and now the atoms will create an absorption shadow in that laser beam, and we can image that absorption shadow onto a CCD camera and take a snapshot of the cloud. And I show you an example up here, cloud that has been cooled to 450 nanokelvin. It's about 200 microns long, 0.2 millimeter. And if I now send a light pulse into exactly this atom cloud, this is what we will record in our experiment. We have the photomultiplier signal here as a function of time in microseconds. We have a blue pulse here. That's a reference pulse just recorded with no atoms in the system, just to set the 0 point of the time axis. And then we let atoms into the system, cool them down, launch another light pulse, and now we get the red pulse out. And notice this guy is delayed by 7 microseconds, and that was in a cloud that was only 200 microns long. Now you just divide those two numbers out, and you immediately get, in this case, a light speed of 32 meters a second. We just slowed light by a factor of 10 million. And now by just turning the intensity of the coupling laser further down, we can get the light speed even slower, and we can actually get it down to 15 miles an hour, and that's certainly at the point where I can claim that you can beat light on your bicycle. So at this point, let me also give you a real sense of, before we go on, what it feels like to be a light pulse going through one of our Bose-Einstein condensates. So this little animation here, so we have the condensate illuminate with a coupling laser, then we send the light pulse into the atom cloud, and at the same time I have a reference pulse running here just for comparison. So here's the, we can see what happens when the light pulse starts to enter the atom cloud. The front edge will enter first, of course, and that will start to slow down. But the back edge, that's still out in free space, so the back edge will start to, will run at the normal light speed, so that'll start to catch up to the front edge, and the whole thing will start to compress. And back to the mouse, so now we'll continue. And the more it slows down, the more it compresses and it chugs along, and now it starts to accelerate and just stretches back out when it exits the cloud. And Of course, in our experiments, we are, this is an animation done for light speed reduction of factor of 10. We are talking in the experiments reductions of factors of 10 to 200 million. So that means the light pulse starts out being typically a kilometer long and compresses to only 20 microns, 0.02 millimeters, so less than half the thickness of a hair. So even though our atom clouds are small, the light pulse ends up getting even smaller, so it fits inside the atom cloud. And I should also point out that the light pulse creates an imprint of itself in that condensate, really like a little holographic imprint. And the reason is that within the localized light pulse region, the atoms are transformed into these superposition dark states that I talked about. So in the middle of the light pulse, we have a high intensity. So a lot of the atoms are transferred from that initial 1 state to the 2 state. But outside the light pulse, the atoms are in their original 1 state. And that imprint follows along as the light pulse slowly propagates through, and then it exits out. So now, with all this in mind, let me just give you an example of the kind of fun you can have with this system. So instead of just, these are much more recent experiments, so instead of just creating one condensate of state 1 atoms, let's create 2 separate condensates. So they're really separately created in 2 different atom traps. They have never seen each other before. And what I will now do is I will send a coupling laser in from the right and then send a light pulse into the left, the first condensate there, and slow that down. And what I mean with that, I have, again, a little animation here. So coupling laser comes in, light pulse comes in, and it slows down, it compresses. And what I then do is I turn off the coupling laser. The light pulse will then come to a grinding halt and turn itself off. But the information that was in the light pulse will not be lost because that was already imprinted in the atoms through that little holographic dark imprint. And that imprint will actually stay in the atoms, in the atom cloud, but it will start moving now. It will start moving at a speed of about 200 feet an hour. And 200 feet an hour, so we can see it exits the first condensate and moves out into free space. And we have photographed this whole process in the lab, and you see it over here on the right. We start with the initial 2 condensates of state 1 atoms. We then send the light pulse into the first condensate, slow it down, compresses it, stops it, and we turn it off. And then 1.3 milliseconds later, sure enough, we can see a little matter imprint, a little cloud of atoms out there in free space. So what we have actually created out here in free space, that's a matter imprint. What we have created out here is really a perfect matter copy in the form of a little atom pulse of the light pulse that we have already extinguished in that first condensate. And you might ask, gee, why is it boomerang shaped? Well, the reason is that when the light pulse slows down in this first condensate, this light pulse will slow down most along the center line of the condensate where the densities are highest. So the light pulse itself will develop a boomerang shape as it's slowing down. And that's perfectly mimicked by that atom pulse, by that matter copy. And now as time moves on, the matter copy moves on, and it'll eventually reach the second condensate. And if we don't do anything, well, the matter copy will go through that second condensate and come out on the other side. Now, on the other hand, once that matter copy is embedded in the second condensate, if we then turn on the coupling laser again, lo and behold, out comes the light pulse. So what we have now done is we have stopped and extinguished the light pulse in one condensate, the first one here, and then regenerated it from a completely different condensate in a different location. So let's look at the whole process here. So coupling laser comes in, light pulse into the first condensate, we turn it into a matter copy travels across to the second condensate, and then we turn it back into light, and it just moves off.
This was a presentation from Lene Hou from the Harvard University demonstrating in an experiment in 2001 how the speed of light of about 300,000 kilometers per second can be reduced until zero. An astonishing outcome which makes us aware that it breaks everything in physics what we've known till now. Because the speed of light is in fact the foundation on which all our theories have been built. Maxwell's theory of classical electrodynamics has as only outcome a constant speed of light. And Einstein's special theory of relativity has carefully built his theory around the constant speed of light, and he rather let change time and space than changing the speed of light. And even in general relativity, a whole space-time continuum will be deformed by a gravitational field, while in fact only to keep the speed of light constant. And now, after this demonstration, which has become famous, it's clear that something is missing in our theories. We cannot explain how the speed of light can change from 300,000 kilometers a second suddenly become absolutely zero. We need a new theory in physics to explain this. A theory which really approaches everything in nature in a very different way than we have done till now. And there is somebody who has the answer.
And where you should not. For my ally is the Force, and a powerful ally it is. Life creates it, makes it grow. Its energy surrounds us and binds us. Luminous beings are we, not this crude matter. You must feel the force around you, here, between you, me, the tree, the rock, everywhere. Yes, even between the land and the ship.
Jedi Master Yoda from the Star Wars movies. He speaks about the light, he speaks about the possibility that the Force unifies everything, and that is exactly what we need. We need a unifying property in physics which can unify with Maxwell's electrodynamics, with Dirac's relativistic quantum physics, and with Einstein's general relativity, and that is the Force. But we have to understand that we have to reinterpret our understanding of the Force. The Force is not something that is acting on a particle. The Force is not something that is acting on a body. The Force is something which we have to reconsider. The Earth is not attracted by the gravitational field of the Sun, and a positive particle is not attracted by a negative particle. Fields do not interact with particles, and fields do not interact with objects. Fields can only interact with fields, and they have to be identical fields. And for this reason, only electric fields can interact with electric fields, and magnetic fields can interact with magnetic fields, and gravitational fields can only interact with gravitational fields. They do not interact with other kinds of fields. An electric field will never interact with a magnetic field, and an electromagnetic field will never interact with a gravitational field. And if you see the experiment which general relativity has been built on, the deflection of a beam of light by a gravitational field, then in this theory it is not the curvature of a space-time that deflects a beam of light, but it is interaction between the gravitational field of the object, for example a black hole, and the gravitational field around the beam of light, because there is no light without gravity around it. The Force is the result of the interaction between corresponding fields. The electric force is the result of the interaction between corresponding electric fields. The magnetic force is the result of the interaction between magnetic fields, and the gravitational force is the result of the interaction between gravitational fields. Fields are not located at a point or at the surface. Fields stretch out over an infinite space. There are no boundaries for fields. And the interaction between corresponding fields stretches out over an infinite space. When we want to calculate the result of the interaction between corresponding fields, we have to integrate over an infinite volume the interaction force density corresponding to the electric fields or the magnetic fields or the gravitational fields. To calculate this interaction, we use the divergence of the stress energy or the energy momentum tensor for the electromagnetic field, and in the next section we will also add the tensor for the gravitational field, which results in an equation expressing the force densities separated in the electric force densities, the magnetic force densities, and the gravitational force densities. On top is the four-dimensional force density, which equals the four-dimensional divergence of the stress energy momentum tensor. And for a perfect equilibrium, the total sum of all the force densities has to equal 0. When we calculate these divergence of the four-dimensional stress energy tensor, we see below the outcome, which is in blue the inertia term for the electromagnetic radiation, in red the two terms for the electric force densities due to the interaction between two electric fields, in purple the magnetic force densities due to the interaction of two magnetic fields, and the two green terms represent the gravitational interaction force densities due to the interaction of two separate gravitational fields. We have to understand that fields permeate each other completely. The electric fields permeate each other completely over an infinite space. The magnetic fields permeate each other over an infinite space. And the gravitational fields permeate each other over an infinite space. The electromagnetic gravitational force density equation illustrated above delineates the characteristics of an electromagnetic gravitational field A as it interacts with itself. Presented below is the analysis of the electromagnetic gravitational field A as it interacts with another electromagnetic gravitational field B. The electromagnetic gravitational force density equation illustrated above delineates the characteristics of an electromagnetic gravitational field A as it interacts with itself. Presented below is the analysis of the electromagnetic gravitational field A as it interacts with another electromagnetic gravitational field B. The electromagnetic gravitational field equation presented above finds applications in the propagation of light, electromagnetic radiation, and the transmission of gravitational waves. The applications of the electromagnetic gravitational field equation depicted below include the interaction between a gravitational field and light, which manifests as gravitational redshift, as well as the interaction of light with matter, specifically the reduction of the speed of light within a Bose-Einstein condensate at very low temperatures. As an initial example, illustrating the application of the second equation for force density between two distinct fields, consider an electrically charged sphere with charge QB positioned within a constant electric field EA. It is crucial to understand that the electric force is not confined to a singular point or surface. Instead, it emerges from the interaction between two electric fields A and B that are fully interspersed throughout an infinite space. Consequently, the local interaction between fields A and B can only be characterized by a force density measured in Newton per cubic meters, which varies with position and direction. The volume integral of this force density over the infinite space provides the total force exerted on the electrically charged sphere B by the electric field A. It is vital to acknowledge that the electric field strength generated by the charge QB differs in both magnitude and direction at each point in space. In the absence of a magnetic field and a gravitational field, only the interaction between the two electric fields A and B remains. The electric field around the sphere is irrotational, which causes the curl term in the equation to vanish, leaving only the divergence term. According to Gauss' law, the divergence of an electric field equates to the charge density. The volume integral of the charge density corresponds to the charge QB. The result of the volume integral of the electric force density interaction over an infinite volume is equivalent to Coulomb's well-known law. This calculation concludes that the resultant force exerted by an electric field on a charge is not merely the effect of a field acting on a charge, but rather the outcome of the interaction between two different fields, with this interaction extending over an infinite volume. As a second example, demonstrating the application of the second equation for the force density between two distinct fields, consider a mass mb situated within a constant gravitational field Ga. It is imperative to recognize that the gravitational force is not restricted to a discrete point or surface. Rather, it arises from the interaction between two gravitational fields. the constant gravitational field Ga and the gravitational field generated by the mass mb. This mutual interaction in terms of force density is seamlessly distributed throughout an infinite space. Consequently, the local interaction between fields A and B can be exclusively characterized by a force density quantified in Newton per cubic meter, which exhibits variability with respect to both position and direction. The volume integral of this force density across the infinite space yields the total force exerted on the mass mb by the constant gravitational field Ga. It is essential to recognize that the gravitational acceleration produced by the mass mb varies in both magnitude and direction at every point within the spatial continuum. In the absence of both an electric field and a magnetic field, the interaction between the two gravitational fields A and B becomes the sole focus. The gravitational field surrounding a sphere is irrotational, leading to the elimination of the curl term in the governing equation, thereby leaving only the divergence term. The divergence of a gravitational field is directly proportional to the mass density. The volume integral of this mass density is representative for the total mass mb. The outcome of the volume integral of the gravitational force density interaction over an infinite volume corresponds to Newton's well-established second law. This analysis indicates that the resultant force exerted by a gravitational field on a mass is not merely the consequence of the gravitational field acting upon a mass, but is, in fact, the result of the interaction between two distinct gravitational fields, with this interaction manifesting over an infinite spatial domain. This third example discusses the projection of a slide onto a screen, a physical marvel of equilibrium at every location, in every direction and at every moment in time. Light is a manifestation of equilibrium. It is only through this unique balance that images of galaxies can reach an observer, such as the James Webb Space Telescope. Unchanged after billions of years, this new theory elucidates this unique equilibrium. A manifestation of electromagnetic or gravitational origin can only exist when this unique equilibrium is present at every point, in every direction and at every given moment. A manifestation of electromagnetic or gravitational origin can only exist when this unique equilibrium is present at every point, in every direction and at any given moment. Consequently, such a manifestation must be a solution to the electromagnetic gravitational equilibrium equation. The light conveying the information displayed on the screen must maintain equilibrium with itself and its environment. When the direction of projection aligns with the z-axis, The plane of projection resides within the xy plane. The adagium, or guiding principle, of this new theory asserts a universal equilibrium expressed in the condition that the sum of all electric, magnetic, inertial, gravitational and relativistic forces is always equal to zero at every location, in every direction and at all times. Equilibrium in the x direction is achieved as the outward radiation pressure is counterbalanced by the inward electromagnetic interaction force. Light is an electromagnetic phenomenon that remains in equilibrium with itself and its surroundings, resulting in the elimination of the gravitational term in the fundamental equation. A decision must be made regarding which phenomenon is being described. If we are considering an electromagnetic phenomenon that is in perfect equilibrium with itself and its environment, we then refer to the intrinsic equilibrium electromagnetic gravitational field equation. For the interaction between two distinct electromagnetic fields, we employ the electromagnetic gravitational coupling field equation. This is the equilibrium of force densities in electromagnetic fields. This slide presents the critical equilibrium achieved within an electromagnetic field where the outward radiation pressure, force density, denoted in Newton per cubic meter, is exactly counterbalanced by the inward electromagnetic interaction force density. This equilibrium is fundamental in maintaining the stability of the system, ensuring that the generated electromagnetic fields do not result in unbounded expansions or contractions. When these force densities are equal, the system is in a state of equilibrium, illustrating the precise balance between the expansive radiation, pressures and the contracting electromagnetic interactions. This balance is critical for the stability and functionality of various physical and engineered electromagnetic systems. This approach results in two distinct field equations: an intrinsic field equation that describes the intrinsic equilibrium of an electromagnetic gravitational phenomenon in balance with itself and its environment, and a coupling field equation that delineates the interaction between two distinct electromagnetic gravitational fields. This reciprocal interaction extends across an infinite volume. For any given experiment or phenomenon, a choice must be made regarding which aspect is being described. If the focus is on an electromagnetic phenomenon that is in perfect equilibrium with itself and its surroundings, we refer to the intrinsic equilibrium electromagnetic gravitational field equation. Conversely, when considering the interaction between two different fields, we utilize the electromagnetic gravitational coupling field equation. The phenomenon of light's speed reduction in a Bose-Einstein condensate at microkelvin temperatures is described by the coupling of the intrinsic field equation and the coupling field equation. A light beam manifests an intrinsic equilibrium with itself and its environment. Thus, the propagation of light must be a solution to to the intrinsic field equation. As a solution to this intrinsic field equation, we present an arbitrary intensity distribution in the xy plane, denoted by the function g as a function of xy, along with a general function f, function of z, t, the time, representing any wave phenomenon as a function of propagation direction, wherein the wave phenomenon moves at a constant velocity. This propagation of light is a manifestation of intrinsic equilibrium. For instance, consider the propagation of a laser pulse. The velocity of this light wave's propagation is entirely determined by the intrinsic equilibrium within the wavefront. Additionally, there exists a counterforce, the inertia of energy. When the radiation pressure exceeds the opposing inertial force, the wavefront is accelerated, and conversely, when the radiation pressure is less than the inertial force within the wavefront decelerates. The upper equation represents the radiation pressure, while the equation below describes the inertial force density. Only under the intrinsic equilibrium condition, where both densities are equal at every location, in every direction and at all times, can this electromagnetic phenomenon exist. This particular intrinsic equilibrium condition can only be realized when the propagation speed of the phenomenon precisely corresponds to the speed of light. The constant value of the speed of light, defined as the inverse of the square root of the product of the permittivity epsilon and the permeability mu, serves as a fundamental expression of a pervasive intrinsic equilibrium between the propelling radiation pressure and the opposing inertial force density. As light propagates through a transmissive medium, such as a crystal within a Bose-Einstein condensate, an interaction emerges between the electromagnetic field of the light beam and the electromagnetic field of the atomic dipoles in the crystal. Consequently, a solution for the coupling field equation is selected to calculate the resultant speed of light. The solution presented here portrays the atomic dipole field in blue, the electromagnetic field of the laser pulse in purple, and the red term represents the inverse value of the refractive index for light within the crystal at the chosen frequency. At extremely low temperatures, on the order of microkelvin, the resonating dipoles form a synchronous field within the crystal. As the light frequency approaches that of the resonating dipoles, the refractive index increases dramatically, approaching infinity when both frequencies coincide. At this point, the light comes to a halt, as if it is absorbed into the atomic structure of the crystal. This equation represents the intricate dynamics of electromagnetic interaction within a Bose-Einstein condensate under conditions of perfect equilibrium. In this state, all electromagnetic force densities reach a constant zero across all dimensions and moments. Consider a laser pulse, a function of the z and the t, advancing with a light speed modulated by the vector colored in red along the z-axis and juxtaposed with a synchronized electromagnetic wavefront, represented by cosinus omega t, enshrined within the low temperature confines of a Bose-Einstein condensate. The ensuing interaction between the magnetic fields of the laser beam and resonating atomic dipoles is defined by an equation, 22 in this example, and it has been published in a site from Mathematica where you can reproduce the same equations with the same outcome, and where the propagation velocity of light is contingent upon the values of the inverse value of the refraction index and the resonance frequency omega. Notably, when the inverse value from the refractive index coincides with the frequency omega, light velocity achieves a quintessential value c, indicating a scenario absent of electromagnetic interaction. Findings from the coupling equation unveil that the speed of an incoming laser beam is capable of substantial reduction, even approaching nullity when the emitted light nears the resonating atomic dipole field. This specialization occurs through an intensified electromagnetic coupling as the dipole fraction term, the inverse value of the refraction index, approaches a critical point, bringing the photon's velocity towards cessation. Such interaction strengthens, causing a deceleration of the photon, demonstrating the coupling factor's paramount role. Notably, the parameters suggest that the dipole interaction term must not exceed unity, as surpassing this render the electromagnetic field components imaginary, thereby necessitating light speeds that remain beneath the universal vacuum threshold. At the extremity, when the coupling factor approaches zero, theoretical implications garner intrigue with the possibility of halting light. Instead of moving freely through space, the photon becomes effectively captured by the atom, amplifying profound implications for our comprehensions of light-matter interactions within the Bose-Einstein condensate states. This revelation propounds a domain where light transitions beyond mere wave dynamics to intimately engaging atomic structures. It posits potential for photon absorption at diminished velocities, fostering advanced quantum systems paramount to fields such as quantum communication and computing, and revolutionizing nanoscale light manipulation. Moreover, the capacity to decelerate light emphasizes the crucial balance between light and matter, spotlighting dipole interactions as fundamental determinants of electromagnetic behavior within condensed matter configurations. Investigating this phenomenon may catalyze innovative advancements in optics and quantum physics. To conclude the examination of these intricate equations elucidates the capacity for drastic modulation of light velocity amidst resonating atomic dipoles, illustrating a regime where the inverse value of the refraction index proximity to zero halts photons' movement, thereby entrapping it within an atom. Such insights deepen our quantum optics comprehensions and pave avenues for further explorations into light-matter manipulation at unprecedented dimensionalities.